all. Today we will start with our DSA journey. We will use a great DSA visualizer. It helps us visualizing DSA, practicing the problem in the right way, in a structured way. This is dsa.chaicode.com. You have to go there. Just go to DSA visual and start it. So today we will start with two pointers. Two pointer is a concept in DSA. Here we use two pointers. That means we will take two variables. To be very honest, we will take two variables and iterate them through the array or string, whatever we get. Okay, so let's take there a simple example here. So we take a left pointer at the start and a right pointer at the end. Okay, then we take those values, we iterate through the pointers whenever we need it. If we need to increase the left pointer, we increase it. If we need to decrease the right pointer, we decrease it. The left pointer always starts from 0 and goes till the last index of the array, and the right pointer starts from the right, that is the last index of the array, and goes toward the 0th index of the array. Okay, and we stop when the left equal to right. Okay, so now write the pseudocode for it. You can see here the pseudocode, which is a solution. You can just go there and write your own pseudocode, just like take left as 0, right as in -1. Okay, then while left is less than right, then we will take the value of ARR of left ARR of right, take and perform operation on the values and plus plus or right minus minus in some do both left plus plus and right minus minus. That's it. We just put here and we just go and eval our pseudocode here. Let's check if we make any mistake or not. The AI will read our pseudocode according to the question and it says we nailed it. Great job, your approach is perfect. Okay, so you can just show solution and get a very beautiful pseudocode. Even you get the state here that left at 0, right at 6, then take those values, move forward. Okay, that's it. Here you can get the time complexity and space complexity also. Okay, let's go to the next, and which is a problem of two pointers, that is two sum problem. It is a very famous problem. You can see the tags here. Okay, so here let's go directly into practice mode, and also mention that you can directly go to lead code here and solve the question here. Oh, just give me a minute. I solved it previously also. So let's start with the question, that is two sum. Okay, so what is given? Given an array, given an one index array of integers sorted in non-decreasing order, return the indices of two numbers that add up to a given target exactly. A target exactly one solution exists. You may not use the same element twice. Okay, let's understand the question first. So we have a array and the value of array is 2, 5, 8, 11. Sorry. 2, 5, 8, 11, 15, 19, and we have a target that is equal to 19. Turn 2 index, turn 2 index where array of I plus array of j equal to target. This is the question. So just come here and see in this question which of the two index, if we add them, we get the value 19 in this array. Simply that is these two index. It is a one base array, so this will be 1, 2, 3, 4, 5, 6. So this will be the array indexes. So index 3 and index 4, we get it. But the question is, how can we solve this? Let me just copy this array once again here. Okay, so how could we solve this? A very brute force method of this solution is using two loops. The first loop start from the index 0, that is this, or index 1, whatever you say, and the second loop always start from the next index of the I. Okay, so we use two loops. We start from 0 in minus 2 and from I plus 1 to 1. Okay, now why here is n minus 2 and here is n minus 1? Let's understand this in a visual manner in this website. Okay, just okay. So our target is 19. We can clearly say this is our practice ground. Left it. First, the loop started from 0th index. Okay. Then the ith loop started from 0th index. We need now the jth loop because we are using two loops. The j always start from I plus 1. Can you see here? The j always start from I plus 1. That's mean 0 plus 1, 1. The j start from here. Now add the numbers. Add array of I plus array of j. So array of 0 plus array of 1. 2 plus 5, that is 7. This is array of 0, the I at 0, the j at 1. The sum is 7. The target is 19. Is the sum equal to target? No. Let's go to next element. Increase the j. Now 2 plus 8 10. Does it equal to sum? No. Then go to j, is next index of j. 2 plus 11, that is 13, not equal to target. Then 2 plus 15, 17, not equal to target because target is 19. Then again goes to the last index, that is 19. So 2 plus 19, it is 21. Target is 19, not equal. Now the j at the last index, now increase the I. Okay, we increase the I. Now j will be I plus 1, that is the next index. So now array of I is 5, array of j is 8, sum is 13, not equal to 19. Increase. Go to the next element. Sum is 16, target is 19. Next element. Sum is 20, target is 19. Next element. Sum is 24, target is 19. Next element. Another loop. Now I start from index 2. J start from index 3. Now add them up. 8 plus 11, 19. Sum equal to target. We reach it. We reach the place where we where target sum equal to target. And we got our answer. Let's write the pseudocode for it. We are getting a we are taking a function. Just sorry, extremely sorry. Okay, so this is the brute force of the two sum. You see here. Now write the pseudocode for this. That is, we are taking a function of array, or rather sorted array, and a target. To run two loops. So for I is 0, sorry, yes, I initial is 0 to I less than n minus 2. The element of array of ARR of I. Then again a for loop. It started from I plus 1 to j less than n minus 1 if error of I plus error of j equal to target, then simply return I and j. Okay, so this if statement ends here, this for loop ends here, and this for loop ends here. At the end, because the question stated exactly one solution exists, we don't need to return any null values here. We just go and evaluating. We did it. Great job. Your approach is solving to some problems in brute force method is sound correctly. Now go to edit my answer. This is my pseudocode. Now go to lead code and solve the question using this pseudo. Okay? I am just taking this pseudocode. This is the pseudocode that we have. We just have to write this pseudocode in our language. I am using C++ for this. Just take it. We got the numbers. You can clearly state that it is a sorted non-decreasing order. But for n, first take the size of the array, that is numbers. So it is numbers dot size. Take a for loop for I equal to 0, I less than n minus 2, I plus plus. Then for int equal to I plus 1, j less than n minus j less than n. Actually this is the end index. We have to take this here because last index doesn't count. So if numbers of I plus numbers of j equal to this will not work. Let's take a sum. Let's take a sum. We calculate the sum. Sum equal to target. Then simply return the indexes I plus 1, j plus 1. Why I did I plus 1 and j plus 1? Because the array is 1 based indexing. So we have to make sure to plus 1 this. Okay. And at the end we can return a null array. Let's run it. Let's submit it. It will give me a, I think a TLE. It's give me a TLE. This is the pseudocode. This is the code in C++. You can write the code in any of the language, your favorite language, if you understand this. Now go for the most optimized approach. Okay, here for this program the time complexity will be big of n square, the space complexity will be big of 1. Let's go to the next, that is the optimized two pointers approach. Okay, so this is the old pseudocode here. So take it. This is a sorted array. We have to use two pointers. Let's take two pointer. One as I, third one is j. Let's take two pointer I and j and put the first pointer at the very first index and put the another pointer to the last index. Okay, what is our target? Our target is 19. Target is actually 19. We have to take two elements that add up to 19 in this sorted array. So what this two pointer does, first it we take two pointers I and j, put one pointer at the starting, another pointer at the end. Now calculate their sum and compare with target. Let's visualize it with here. First, we put the left pointer at the very start and the right pointer at the very end. You can see here, left at 0 index, right at index 5 or the last index. Now add them up. So 2 plus 19 will be 21. Okay. So now 2 plus 19 is equal to 21. We get 21. Our target is 19. Okay, so we don't get our target. And 21 is greater than 19. Okay, remember it. Now let's come back here. Sum them up. Okay, so let me just, yes, this is actual pseudocode here. The sum is 21. So now the sum is greater than the target. You can clearly see here the sum is 21. The sum is 21. The target is 19. How we get the target here? Let's think of it. The array is in sorted order. We have two pointers, one at the start, another one at the end. We add the elements. Now we get the sum which is bigger. So we have to reduce the sum here. We have to reduce the sum here. How? How we can reduce it? Let's think of it. What if I move the j pointer one step back? Why I did so? Because observe this array. This array is actually in a sorted order. Okay, so 19 is bigger element. So the element just before 19 is smaller. 15 here. 15 is smaller than 19. And we have to reduce the sum here. We have to reduce the sum here, and we just move our pointer to the smaller element. Our biggest point, the pointer which stored the biggest value, we reduce it to the lowest value. Okay, not the lowest, the second one. Okay, same thing we did here. We go there, we take the sum is 21, target is 19. We have to make sure the right pointer now move to 15. The right pointer now move to 15. Now 2 plus 15, that is 17. 17. 17 is less than 19. 19 is our target. We got 17. So for this case we reduce the sum. For this case we increase the sum. But the same question, how could we increase the sum? We have two ways. We have to increase the sum. So we have to move these two pointers only. So what if I move the ith pointer to the next element? Now it's pointing towards 5 because 5 or the next element of I is always greater than the current I because the array is sorted. So we just increase the pointer I so that we got a bigger value. Why not we increase j? Because we already tested that j has a bigger value, so we reduce the j. Now we got a smaller value, so we increase the I. Okay, you can see here also the sum is now 17, the target is 19. We just increase the left pointer. Let's see, left is here. Now increase the left. Now 15, 5 plus 15, 20. So 20 is greater than 19. What we did when the sum is greater than target? We reduce the right pointer, this right pointer should be reduced. We reduce it. Now 5 plus 11, then sum is 16. The sum is 16. So now the sum is less than the target. So what should we do? We have to increase our left pointer. We increase our left pointer. Now left at here, right at here. Sum this 8 plus 11, 19. We get our sum. Just answer it. Let's write the pseudocode for it. We are taking another function. We will take a array and target. First, we have to make sure we have two pointers. So left at 0 and right in -1. The question is till which point we have to increase the left and decrease the right. Okay, let's see. Here actually, we increase it, we decrease it. Now if we increase this and if we decrease this, now I is greater than j. This is the point where we have to stop. When I is greater than j, we have, okay, this is the point where we should stop. This is, so while left is less than right, so till the left is less than right, like this, we have to perform the following operation. Calculate the sum, like AR of left plus AR of right. Okay, then at the last, what we get here, we get the sum and the target, we get the answer. Here the sum is 19, the target is 19. What we did this time, we return the indexes. So if sum is equal to target, okay, so it's a pseudocode, we don't need brackets. Target, then we have to return left and right, and if sum is equal to target, we got the indexes, we return it. Else if sum is greater than target, what we have to do here, the sum is greater than target, what we did here, we reduce the right pointer. So right minus minus, or in else case, which is now the cases if sum is smaller than, this case the sum is smaller than the target, we just increase our left pointer here. We increase, so left plus, we increase our left pointer. Now just go and evaluate it. Let's see what happened. Nailed it. We just nailed it. Great job. Now then copy this, go to this problem, paste this, write the code in any of your language. I am using C++ here. So first we have to take the size, which is n, equal to numbers dot size. Then what we do, we point two pointers, one at left, another one at right. Left, so int left equal to 0, int right equal to n minus 1. Now while left is less than right, to first calculate the sum, so int sum equal to numbers of left plus numbers of right. If sum is equal to target, we have to return the indexes. If sum is equal to target, then we have to return left plus 1 and right plus 1. We are doing plus 1 here because it is an one indexed array. So else if sum is, let's, greater than target, sum is greater than target, what we have to do, we have to do right minus minus, and for the else case we have to perform left plus plus, and at the end you, what I prefer to return a null array. Let's run it and see. Yes, it's running. If we just run it, yes, it accepted. Sorry, this is one of my extension. So this is the pseudocode, this is the whole code. A very great platform to practice. You can use a pseudocode. This is my pseudocode. Let's say it is pseudocode. If we go to solution, we get the we get this pseudocode. The pseudocodes are different, but the AI, when we click on this evaluate, the AI is checking that is our pseudocode right according to the problem. Okay, so definitely go check out this platform. It is dsa.chaicode.com. I have mentioned this. This is the platform, dsa.chaicode.com. Go and use it, and it is a paid platform. I am a paid user, so just go and use this coupon code. Use this link. Use this link. I will paste the link in comment also. Paste this link in comment also. If you use this link, you will get a 7-day free trial on this platform. 7-day free. Just go use this sign up link in the comment. I also will give you the website link, that is dsa.chaicode.com. Go use it. You can see your streak here, that how many problems do you solve, what is your streak, and the days you missed and everything. Really good platform, really good thing. Go check out. And thank you for today. Today we learn about do sum problem. Next day, let's say tomorrow, and with some another problem with solution using this amazing platform. Thank you.